the 11th question, it is asking you about the smallest prime number. That is the sum of 3 different prime numbers. So I would say that this is number theory. And it's about primes. Okay? So, well, let's think about this. Can we use the prime number 2 if I want 3 different prime numbers to add up to the smallest prime number? Apparently not, because 2 is the only even prime. That's poor handwriting. 2 is the only even prime. Yet, if I'm adding 3 prime numbers, the other 2 must be odd, right? So even adding odd, that's going to give us an even number, which is not a prime. Because any other even numbers apart from 2 cannot be a prime. So it means that the smallest possible number I can make with 3 odd primes is going to be 3 adding 5 adding 7. That's 15. But 15, again, it's not a prime. So I'm looking for the second smallest. Now, of course, I want to just change one of them, which is the greatest one, into the next prime number to make it the second smallest. So I have 3 adding 5 adding 11. And that is 19. So this time it is a prime. So the answer is 19. Okay? So you can either try it out or just use this logic to solve this question. All right? First of all, we need to know that 2 cannot be involved. And then we're just moving on to trying all the smallest possibilities one by one. Okay? And question number 12, I can't believe this is question number 12 because it is actually very, very easy. So again, this is a word problem with fractions. It says that a fish weighs the total of 2 kilograms plus a third of its own weight, which means that if this is the weight of a fish, it's going to be a third of its own weight and 2 kilograms. Which means that 2 kilograms is 1 take away a third, which is 2/3 of the weight of the fish. So if 2 kilograms is 2/3, the weight of the fish is going to be equal to 2 divided by 2/3, which is 2 multiplying 3/2. And we can do the simplification there to see that it's going to be 3 kilograms. So the answer is B. All right, as simple as that. And question number 13. Question number 13, it is actually, well, let's say slightly more interesting. I would say that this is the hardest question in the first half of this paper. So this is going to be a counting question, but it is kind of mixed with number theory. So let's say it is a counting problem on, I would say it's either counting shapes or like the law of multiplication. And addition. So what it means is that whenever I can make some choices, when I can only make either this or that choice, then the number of choices I have needs to be added up. if I can make this choice first and that choice next, I use multiplication to multiply them up. Right? For example, like, well, if I am just trying to buy a meal deal, then I have different choices for the mains, different choices for the drinks, but I need to choose both of them, so I multiply them up. But if I'm choosing either a drink or a main, I'm adding the choices up. So if I have 3 choices for the drinks, 2 choices for the main, altogether, if I'm just choosing either of them, it's going to be 5 different choices I have, right? So that's the idea of it. Now, in this question, you can see that each line joining 2 numbers is to be labeled with the sum of the 2 numbers that are at its endpoints, right? And we want to know how many of these labels are multiples of 3. Which means that how many lines are joining 2 numbers that adds up to a multiple of 3. So, well, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 numbers. We can classify them into 3 different sets. The first set is 1, 4, 7, which they have a remainder of 1 when divided by 3. The second set is 2, 5, 8, which they have a remainder of 2. And the third set is 3 and 6, which they have a remainder of 0. So, when they are joined up, how would they be divisible by 3? Or how would they be multiples of 3? Well, it's only when the sum has a remainder 0, right? So if I am starting with a number that is having a remainder 1, for example, like 1, I need to join it up with a number with a remainder 2, such that the remainder will be 3 altogether. When the remainder is 3, we know that the remainder is just 0, right? Remainder 3 is remainder 0, because every 3 is going into 3. So it means that any numbers in 1, 4, and 7, which belongs to remainder 1 category, can be joined with any number in the remainder 2 category, 2, 5, or 8. So we have 3 different choices for remainder 1 category and 3 different choices for remainder 2 category, which means that altogether there will be 3 times 3, which is 9 choices, because I need to choose one out of both, right? So just like 3 mains, 3 drinks, I've got 9 choices, 9 different combinations. So 3 remainder 1s, 3 remainder 2s, I've got also 9 choices. So finally, what about the remainder 0 category? Well, we know that a number can't be joined to itself, right? So 3 and 6 can only be joined to each other to make sure that it's not having any other remainders. So that's only going to be 1 choice. So you can imagine that those 9 lines between 1, 4, 7 and 2, 5, 8, adding this 1 line between 3 and 6 is going to make a 10 altogether. Okay? So that's all we have. All right. And then the next one is question 14. So I would say that this is pretty easy. This one is pretty easy as long as you can understand what the question means. All right. So this is, again, I would say a number theory question on prime numbers. So it is asking you how many digits are both prime and represented by a prime number of illuminated bars. First of all, we just need to choose the prime numbers, 2, 3, 5, and 7, right? So we can eliminate all the rest. And then we count the number of bars that are used for each of them. So for 2, it is 1, 2, 3, 4, 5, using 5 bars, which is also a prime. So we know that 2 works. For 3, it is using 1, 2, 3, 4, 5 bars, which 5 is a prime. So 3 works. For 5, we are using 1, 2, 3, 4, 5, 5 bars, so 5 works. For 7, it is using 1, 2, 3 bars, so 7 works as well. So altogether, you can see that all 4 of them works. Which means that the answer is going to be 4. Pretty easy question, isn't it? So the last one for the first half of this paper, it's again a number theory question. And you can say that it's about prime factorization or it's about factors, whichever you want, okay? But I would say that it's more related to prime factorization. First of all, I need to know if any of them is divisible by all the integers from 1 to 10. So it means that it has to be a multiple of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first thing I can do is to make this question a little bit simpler, which is that I can try to cross out some unnecessary numbers. For example, 10. 10 is definitely unnecessary because whatever is divisible by 2 and 5 has to be divisible by 10 as well. So we can cross out the 10. As for 9, you can see that it is 3 to the power 2. So it needs to be divisible by 3 and another 3, which means that it is necessary. But then now 3 is unnecessary because whatever is divisible by 9 is also divisible by 3. As for 8, it is 2 to the power 3, which means that 4 is covered by it and 2 is covered by it. Of course, the 1. I should have eliminated it much earlier because anything is divisible by 1, right? Except for 0, of course. So as for 7, well, it can't be covered by anything else. So we keep it there. For 6, well, if something is divisible by 2 and divisible by 3, it will be divisible by 6. And whatever is divisible by 2 and 3, no, I should say, whatever is divisible by 8 and 9, which we have left over, must also be divisible by 2 and 3, of course. So 6 is also unimportant, which can be cancelled out. Now, we just have 4 numbers left, 5, 7, 8, and 9. We just need to check which multiplication is divisible by all these 4. Well, 45 is 5 times 9, 56 is 7 times 8, so definitely the answer is C. All right? So that's how we can work it out. Okay, so that's everything for the first half of this 2015 paper. I hope you did understand everything, and well, I will see you next time. Probably tomorrow, because I will be explaining the first mock we have. Or if you're not free tomorrow, I will just see you in the playbacks, or I will see you on Thursday again. Okay? So have a nice day, everyone. I will see you next time. Bye-bye.